This Week in Radio Tech, episode 238, is brought to you by Lavo and the new Crystal Clear Virtual Radio Console. Crystal Clear is the radio console with a multi-touch touchscreen interface. By the new Omnia 7 FM and HD audio processor with Undo technology. Omnia 7 is a mid-priced audio processor with the sound and features you love. And by Axia Audio and Livewire sound card replacement. Get your PC out of the XLR era with Axia Audio over IP. How has the move to digital audio changed audio routing and workflow at TV stations? Well, Gibson Prichard should know. He's the chief engineer for Journal Broadcasting's WTVF-TV News Channel 5, the CBS affiliate in Nashville. Self-educated in broadcast engineering, Gibson started at a local FM station and has worked through digital and HD upgrades at 2 TV stations. Hey, welcome into This Week in Radio Tech. I'm Kirk Harnack, your host, and so glad that you're here with us. This is the show where we talk about everything from, this thing, the microphone, to the light bulb at the top of the tower. I've got one of those here in the office. Sometime I got to turn the camera around and show it to you. I've got a 300 millimeter code beacon here in the office. We'll check it out another time. Our show is brought to you by the folks at Lavo and the Lavo Crystal Clear console, the virtual mixing desk. Also by the folks at Omnia and the new Omnia 7 audio processor. It's amazing, and it's family priced. And also by the folks at Axia and the Axia IP audio sound card replacement. We'll tell you about that in just a few minutes. Let's bring in our guest. It's just me and our guest today. That's it. That's all you're going to get. Our guest is Gibson Prichard. Gibson, hey, Gibson. Gibson, you are the chief engineer at, I guess, the #1 television station in Nashville, the CBS affiliate, WTVF, and I guess, WTVF, do you still call it TV or do you call it DT now?
Well, I think the DT went away when we shut the analogs off. So most stations are just called their call letters or their call letters -TV, and that usually stemmed from if there was a co-owned AM or FM. If the call letters were ever also associated with an AM or FM, whether they are today or not. Sometimes a TV suffix, is indicative of an AM or FM with the same call letters. But the DT stuff went away in 2009 when we turned the analogs off and everything was digital.
Gotcha.
But you still see it pop up from time to time.
So the show is called This Week in Radio Tech, and so some people may be asking, why do you have a television engineer on there? They don't, that's just radio with pictures. And Gibson brings to the show experience in both radio and television. I met Gibson, some years ago. Actually, I probably met you, Gibson, when you were already at a TV station. But just prior to meeting you, you had been the chief engineer at one of my favorite stations, Lightning 100, WRLT here in town. How did you get into broadcast engineering of any kind?
Well, that's a very interesting question because it's not a path that is one that I've probably shared by many other people. I started in sales. Started selling radio advertising. I was out of college about 25 years ago or so and was looking for a gig like everybody else is at that time. And I applied for a sales job, figuring that's what was open. And I had some sales experience in college. So I got a job in sales, and to put it politely, I was not blowing the doors off the sales numbers. And around that time, the station for whom I was working, which is Lightning 100 here in Nashville, was in receivership, owned by a bankruptcy court. And they had a couple people leave, and I became a traffic and production guy. The chief engineer was a position held by a contract person, as many, it's common in radio engineering, of course. And I sort of taught myself the engineering. We needed things done. We needed CD players hooked up or microphones fixed or things done on remote. And when the engineer was only being paid to keep the station on the air, I was the one I picked it up by default. I taught myself engineering. I think I figured most of it out along the way. I had several people mentor me. And I was there for about 5 years. Moved the station, built 2 additional transmitter sites when we purchased 2 other stations. And I've learned quite a bit. I learned computer networking. I learned audio networking. I learned analog audio cabling, AES cabling, RF engineering, and I was blessed with the ability to pick things up rather easily. Then I got a call from the chief engineer at a TV station in Nashville said, I hear good things about you. Maybe you'd like to come work, in television. Honestly, never thought about it, but
I got to interrupt you. You're blowing my mind. I had no idea that you didn't have formal education in some kind of electronics. Because Gibson,
well, I have a college degree. I have a college degree, but it's in communications. It's in TV.
Right. What does that mean?
TV it's in public relations. How to be a disc jockey. How to edit video. How to write commercial copy. How to how to do PR.
That's
nothing to do with technology.
You went to Mississippi State. Do you still follow the Bulldogs?
Yes, I do, Kurt. I do. Okay. I do. I still have a cowbell. Yes, my kids are very proud of the cowbell.
Okay. Well, I
use it to wake them up sometimes.
I'm glad we had this conversation. I've known you since almost the moment I moved to Nashville, maybe within a year of my moving here almost 14 years ago. And I'm blown away that you are not classically educated in electronics and broadcast gear and that kind of thing, and which is just like me. I have no formal education in this either. I tell people I got shocked enough times to where I learned where all the electrons like to hang out.
Well, sometimes that's what happened to me. I got shocked today just walking down the hall. I drew an arc with some static electricity, and it just made me think for a moment. Wait a minute, there's electricity everywhere we go. It's all around us.
Now I got to tell you, it took me you kind of had a baptism by fire over about a 5-year period. You said that you worked for Lightning 100, and of course, when you moved into TV, you had a whole bunch more stuff to learn. That's much quicker than me. It took me a lot longer to learn whatever it is that I know about broadcasting. But that's just awesome. You said that. Now this is really interesting because I've always thought, I'm a little bit gifted with being aware enough to figure it out what puzzle pieces I don't have yet. I'm able to figure out what it is that I don't know yet, and I can go after those things. How's that? How have you thought about that learning quality for yourself?
Well, if you think about like a puzzle, you always start with the corners. You know where the edges are. You can look in the box, and if they're only cut on one side, that's probably a corner piece, and you start there. Honestly, I think I just have a sense of intuition, so I can look at something, whether it's an audio processor or an audio console or a transmitter, and I can look at it and say, all right, well, I know it's got to end up out one end, and how does it get there? And somehow I can read the schematics and read the owner's manual, and I'm able to pick things up as I go. And I'm sure I made a lot of boneheaded decisions along the way, and a lot of probably did some really dumb things. And some of my former employers might say, well, yeah, he wasn't the smartest kid when he was when he first started here. But honestly, I've just been able to pick things up as I go. I'm pretty good at reading owner's manuals, pretty good at finding things on the internet, asking questions. I know kind of what questions to ask, and I don't. People ask me how I figured it out. I honestly, it's just something I do. It's kind of like walking or chewing gum. I just sort of figured it out and don't really know how to explain it.
We're talking to Gibson Prichard on This Week in Radio Tech, and I can tell this is going to be a really fascinating hour, or what's the 45 or 50 minutes we have left. We're talking about broadcast engineering and not necessarily all the hands-on specifics, although there may be a few things that we get to in the hour. But this is going to be a really fascinating hour because Gibson, turns out, I didn't know this, is very much self-educated. I know a lot of other engineers are as well, so we'll get into that. Our show is brought to you in part by the folks at Lavo. And Lavo is a console company, spelled L-A-W-O. So go to lavo.com and check out this great console. It's an idea that I've always thought was terrific, and it's about time it's come along, and that is a touchscreen console. It's the Lavo Crystal Clear virtual radio mixing console. And by virtual, it means that the surface that you touch, you see that picture right there, the surface that you touch is a multi-touch computer monitor. You can have up to 10 touches on there at once. It's actually a good HP computer with this 10-touch multi-touch screen. You can be touching several faders at once, plus buttons, move things up and down, move things around. It reacts really well. It's a fantastic touchscreen. And the software has been written to look just like a Lavo audio console. So stuff is where you'd expect it to be. What's cool about this is that buttons behave in context to what you're doing. You're not limited by a piece of hardware anymore where a button can, has two wires going to it and it only does this thing. And it only lights up this way. Because it's written in software, the buttons can do anything you need them to do. And so they're very contextual. If you're working with a microphone channel, a microphone fader, and you touch an options button for that channel, you get microphone-based options right there. You can put up to 8 things through the console at once at the same time. There's 8 faders on the control screen. But the engine itself that you plug things into will handle up to, I believe, 24 sources altogether: mic, analog line, and AES inputs. Plus, you can get inputs from an AOIP network from either Ravenna or AES67. Ravenna is AES67 compliant. So if you have other items in your facility that are either Ravenna or AES67 AOIP, then you can bring them in as well. And have 8 up on the console at the same time. Of course, you can switch things that are on the console instantly with no interruption in your audio whatsoever. There's if you mess up the console, whoops, I put all 10 fingers on it once. I'm not sure what I touched. There's a panic button. It clears any changes that you've made and returns you back to the console's default position for that shift. It's got 3 stereo mixing groups: program 1, program 2, and a record bus. Very intuitive GUI. You can really use this thing quickly. Advanced DSP for microphones. So there's mic processing built in and for external sources as well. 2 low noise mic preamps are built in, and of course you can use external mic preamps if you need more than 2 mics. And there's power supply redundancy that's built in as well, plus GPIO for on-air lights, for muting speakers, muting other things around the studio that you might have to. So if you're interested in this kind of technology, and I would hope you would be, it's really cool. Check it out. Go to lavo.com, L-A-W-O. So if I say it the American way, lavo.com, and look for the Crystal Clear. It's under the products and radio consoles area. Then look for Crystal Clear. And sure thank Lavo for their support of This Week in Radio Tech and for really acting on this great idea in audio consoles. All right, Gibson Prichard is our guest. He's the chief engineer at Channel 5 here in Nashville, but he started out in radio. Disc jockey, selling, and
I don't think I was a disc jockey.
Okay.
I probably filled in for a weekend shift once or twice, but I was a disc jockey in college, so I guess that would be accurate. Yeah, I was a college disc jockey.
So making the move, Gibson, from radio to television, I guess I met you at Fox 17, the right. Fox affiliate here in Nashville. So how did that work? What was your confidence level in transitioning to an environment where audio is kind of almost an afterthought sometimes?
Well, it was interesting because as I said earlier, I got a call from the chief engineer at the Fox affiliate who said, somebody told me about you, said you might be a good computer engineer, somebody might want to have on staff to work in IT and engineering because you have RF background. And I said, well, honestly, I never really thought about working in television. My first love was radio. Went to a job interview. We talked about the position, talked about what would be involved and what would be inspected. And after I took the job, what occurred to me was, well, suddenly I had a budget to work with. I had been working at a very small radio station where I didn't have much of a budget, if at all. I suddenly had a budget. I had things I could buy. I didn't have to go beg and borrow for things I needed. And I picked up the video piece. I mean, at the time it was all analog. I had to learn about analog video, but I knew how to put a BNC connector on. I knew I didn't know all the Belden part numbers for the different video cables, but of course I know them now. I understood some of the basic principles. Having gotten a college degree in TV and radio broadcasting, I knew about how to edit, how to make a tape-to-tape edit, which is what we were doing at the time. I understood the basics, and so I understood high power amplification. I had been to a radio transmitter school, so at least I understood the grounded grid transmitter design. Although please don't ask me to come and neutralize a tube or work on your CCA transmitter or your Energionics transmitter. I wouldn't be the guy you'd want to have since I haven't touched one in 15 or 20 years.
A long time.
Yeah. But once you understand some of the basics, whether it's a klystron or IoT, or whether it's a power tetrode or And, you know, I mean, once you understand the principles, and I was just, I guess, somehow lucky in that I was able to make the leap from one to the other. I did a lot of audio work, is what you might expect. I was, you know, connecting audio cabling, you know, doing a lot of audio patch panel wiring. What I was struck with when I moved to television was that, you know, I had options. I had a routing switcher. I had the ability to send audio from one place to the other without a direct cable. I mean, it was directly cabled, but I didn't have to make a dedicated cable. I could, you know, I could use a facility's routing switcher. So that was a real blessing. You know, just
yeah, in small market radio, even medium market radio, we don't always have routing switchers. In my 20-year career as a contract engineer, I never once worked for a broadcast facility that had a whole house routing switcher.
I did some work for a local, or was the Tennessee Radio Network here, that did have a analog audio routing switcher. So I was fortunate that I got to understand that and got to wire it. You know, I had some people along the way who taught me how to do good cabling. You know, it was all 66 style telco blocks. Then graduated to other forms of interconnect, but you know, it just sort of picked it up along the way. And as I said earlier, there's probably some stuff I'd sort of turn my head at and look at it if I did now. And you know, if I were to go back now and look at some of my old work, I might not be so proud of it. But you know, you pick it up as you go, and you know, you certainly recognize the bad. I don't know that I recognize the good so easily, but I recognize the bad work, and you know, just try to do your best.
In a few minutes, I want to talk about your experience in the television world with the transition from analog television to digital television, and the upgrades in studios, and of course, audio often goes along with that. And,
Sure.
and I want to get there. But first, one of the things that you and I talked about in a number of SBE meetings here in Nashville was when Nextel was involved in making some changes in the ENG spectrum, the 2 gigahertz
Right.
spectrum.
Yeah,
And
so
Nashville was one of the markets, I think the smallest market, where stations got provided with some new gear, right?
actually, no, it was actually every ENG market across the country. So for those of you who don't know what ENG means, electronic news gathering. In television, that generally, there are a couple different bands, frequency bands, but generally speaking, there is a little chunk of spectrum around 2 gigahertz, from 1990 to 2110 megahertz, or 1.99 gig to 2.11 gig. And that's what it was anyway. And Sprint Nextel, of course it was just Nextel at the time, it was before Sprint bought them, they said, well, that's adjacent to all the PCS channels right below it. So the transmitters, the handheld devices, the cell phones that we're already building would work just beautifully in that spectrum. So dear Mr. FCC, couldn't we have some of that spectrum? And they said, no, you can't just have it, you can buy it. And they said, well, if we buy it, you know, but the problem was you had to get the incumbent users out. You had to vacate the spectrum of all the TV stations who were using it for news gathering, and some for STLs, although most STLs are out of that band by now. So Sprint Nextel was after 5 megahertz of spectrum, but they had to clear 20 megahertz because there were 3 other chunks that the FCC was going to sell. And so Sprint undertook this enormous plan of paying for all the TV stations to change out their hardware, to change out all their analog FM modulated news gathering microwave for new digital gear. And it was an incredible boon for the people who made the equipment and for the guys who are hanging transmission line and antennas, and you know, but like a lot of things, when it happens out of a mandate, it's a sort of a feast and famine situation. For about a year or 2 years, it was you know, just going gangbusters, and then once everybody got converted, it all dried up. But I mean, if you think just dollar values, you know, with each transmitter being, say, $30,000 that goes in a van. So, and the reason there's so much is because they had MPEG encoding built in. So if a station's got 4 or 5 vans, each transmitter's 30 grand. That's $150,000 just in transmitters for the station. Then you've got the receivers, and then you've got control systems, because basically Sprint Nextel was replacing everything. I mean, everything because that stuff, as you might imagine, was had lasted for ages. TV stations had this stuff around from the 60s, that at the time was 25 or 30 years old. It was still working, and Sprint had to replace it with all new, all digital gear. So it was quite an amazing transition, to be honest. And then so what happened is all the TV stations had our band shrunk by what was that? I guess about 35 megahertz. We lopped off this big chunk at the bottom of the band, and then kept the same number of channels by moving from 17 megahertz channels to 12 megahertz channels.
Oh,
so
okay.
Each channel got 5 megahertz narrower, which 17 megahertz is what you needed to pass analog FM video, but you could do that just fine in 12, actually, or 6 or 8 megahertz is what you need, depending upon the bit rates you do. So that was what happened, because the TV, you couldn't just reduce the number of channels, except in the very, very, very small markets, like markets number 150 and above, where there's just 1 or 2 TV stations doing news. In almost every market, there's at least 3, maybe 5 or 6 stations doing news, each with, a varying number of trucks and operators. But it was a big ordeal, and I was involved with my station's work, but and at some level, for the Nashville market, I am the frequency coordinator for the market through the SBE. But it was an amazing task. I'd kind of forgotten about it. It's now been, that was prior to the analog transition for television, when we turned off the analog transmitter. So it seems like eons ago, but it really was just about 5 or 6 years back.
So was all this new ENG gear, was it capable of high def transmission?
No, well, not directly. Well, yes, okay. in a way. It all was standard definition. So they were all the manufacturers were including standard def modulators, basically MPEG-2 modulation or MPEG-2 encoding, COFDM modulation. So you could put analog video in, or you could put standard def digital video in, and it would be passed through. If you wanted to do HD, you needed to buy some other form of encoder, and then connect it through one of the external inputs, usually called the ASI input, where you can take a digital data stream from an external encoder. So you were essentially using the RF portion of the radio, but not the video components. You were not using the pieces built in. It's sort of like using your computer, but bypassing the sound card and doing something, putting audio in through a live wire interface or something. You're not using the built-in sound card because you want to improve the quality. So that's basically it.
Ah, okay, all right. Well, cool. I remember that being you explaining to a lot of folks what was going on, and be in touch with your Nextel rep and all this, and it seemed really complicated. Hey, we're talking to Gibson Prichard. He's the chief engineer for TV station on This Week in Radio Tech. He's the chief engineer for WTVF, the CBS affiliate here in Nashville, Tennessee. And I'm always pleasured to have a conversation with Gibson, usually after an SBE meeting here in Nashville when we both get to attend. And I'm always finding out, what's new in the market, what's new in technology. And we got a couple of important subjects to still get to. Gibson, besides the transition over to HD and how that affected audio in your TV stations. Right. Also want to end up talking about the internet, the IT router subject that you and I talked about a few weeks ago after an SBE meeting. That's pretty fascinating too. I know lots of people on the who watch the show are interested in such things. So we'll get to that in a minute. Hey, our show is brought to you in part by the folks at Omnia Audio. And I've got a brand new processor to tell you about. I don't think it's shipping yet, but you need to find out about it. For a lot of radio stations, the Omnia 11 and even the Omnia 9 are just a huge financial step. These are $10,000 plus audio processors. Well, our terrific technology partner, Leif Clayson, and you guys know, if you're familiar with Stereo Tool or any of Leif's work, you know how good it is. Well, Leif and Omnia together have come out with a new audio processor called the Omnia 7. I'll put the link to it in the show notes. There's a picture of it right there. It's a smaller version of the Omnia 9 with many of the features that are most desirable still in it. And let's just say it's very popularly priced. You're going to want to get with your Omnia dealer to find out about this processor. It's now it doesn't do all the multiple paths of processing that the Omnia 9 does, but what it is for, it's for FM and it's for HD. It does have that exclusive undo technology that Leif Clayson is so famous for. Records are records. Music is mastered nowadays with such clipping. And it's just, I guess it may be okay for your iPod or for just listening to it, but my goodness, it doesn't code well into bit streams and, bit rate reduced streams. And it's no good for FM, because FM, we're just going to process it more and clip it some more in very intelligent ways. But this undo technology is just amazing. It can take the worst sounding recording that's just clipped to heck. You can look at it right off the CD and it's just clipped as can be, and undo rebuilds very intelligently the peaks that got clipped off. And Leif has some demos of this on YouTube. Of course, your best thing is to see Leif demonstrate this in person. You can really hear it well. So the Omnia 7, just like the Omnia 9, has this undo technology. It's a two-step process that restores peaks and dynamic range and removes distortion from source material that's been damaged by overcompression and clipping in the mastering process, typically. It has a psychoacoustically controlled distortion masking clipper. Boy, that's a big mouthful. Let's just say it sounds terrific. It has Omnia Toolbox built in, which includes digital oscilloscope, an FFT spectrum analyzer, and real-time analyzer to help you adjust your processing and to see what you're hearing. It also has, this is cool, speaker calibration. I haven't tried this out myself, but as soon as I get my hands on an Omnia 7 here in my lab, I'm going to get this speaker calibration going. So I make sure my speakers are EQ'd flat and everything sounds good. It has a dry voice detector that helps it with adjusting the processing moment by moment when there is dry voice being put through it. A remote client that is a joy to use. It's absolutely terrific, very real-time remote control client. So check it out. This Omnia processor, the Omnia 7, is just amazing. I did get to look at one and play with one for a few minutes at the Telos headquarters in Cleveland back a couple weeks ago, and I'm just very excited about it. If you go to the website, omniaaudio.com/omnia-7. So it's omniaaudio.com, the usual Omnia Audio website, and /omnia-7. And check this thing out. So if you couldn't afford Leif's high-end processor before or an Omnia 11, this can do the job for you. I think you're going to like it. Thanks to Omnia Audio for being a sponsor of This Week in Radio Tech. It is episode number 238. We are talking with Gibson Prichard, who is a television engineer, and we're going to get around to talking about audio and some IT issues and subjects that can affect you at your broadcast facility. So, by the way, coming up on another show in the very near future, it's already slipped my mind. We've got a guest next week that I'm very excited about, and I'm sorry, I'm having a senior moment. I'll tell you.
What's his name?
What's his name? Yes.
What's his name? He's great. I can't wait for that, Kirk.
Yeah. Oh, and by the way, excited. Gibson, thanks to your suggestion, my booking agent is reaching out to your suggested guest.
Okay, very well.
The Superman of broadcast engineering, and I didn't even know it.
Yeah.
So let's get around to talking about transition from analog television to digital, and along with that, most people think it was a transition to HD, but really it was a transition to digital, and HD came along for the ride. Is that kind of characterizing?
That's right. That's right. I mean, the FCC said you had to change your modulation from analog NTSC to this 8 VSB method that that we're currently using. And with it, you had to. There were some specifics about it. You had to be compliant so that any tuner could receive it, or any tuner that could receive it could decode it. So that means MPEG-2 video, Dolby AC3 audio. You had to include certain parts of metadata. You had to be able to send things like guide information, clock data. There's a relatively thorough list of what was included, but one of the things looking back in hindsight, that since the what's known as the ATSC or Advanced Television Standards Committee since that system was first proposed and of course adopted by the commission, that's been, well, since like 1992, 95, somewhere in there. So if you go back and think about what was going on in radio technology, 20 years ago, there's a lot that's changed. So if you, if you think about MPEG-2 video being the standard, that's not keeping up with what's current. I mean, most people are using MPEG-4. That's what you get on Blu-ray players. That's what you're getting streaming over the internet from Netflix and Hulu. And then there's, of course, H.265 video, which is coming, which is actually being used by Netflix and Hulu and others. But so what we have is this standard that provides great pictures, and if you transmit high definition, you can transmit great pictures, either 720p or 1080i video. Two major networks chose 1080i, two chose 720p. To most people, they can't tell the difference. There are some reasons they choose one over the other, but that transition for the TV stations required us to go out and purchase new transmitters, purchase new systems to encode the video, to make the MPEG-2 video, make the Dolby AC3 audio. And then in the case of my TV station, we actually had to change channels. We were transmitting on channel 5 in analog. Our what was known as pre-transition channel for our digital signal was on channel 56, which was outside of the core. That was part of the spectrum that the FCC was going to auction off to all the wireless telecom people. So we could not stay on 56. We had to go to another channel. There was a period of time that we looked at it. We went back to channel 5 as our primary signal, which is a low-band VHF channel. Worked great for analog. It covered a long distance. But because of its susceptibility to impulse noise from lights and motors and power lines and things, it really was not all that well suited for digital, particularly people with indoor antennas, because of both the noise and the long wavelength of a channel 5 signal.
Yeah.
So, if you didn't have a rooftop aerial, sometimes you had trouble getting our station, even though we were transmitting with plenty of power. So we, put a translator on. I put a translator on in UHF, and then over a period of time, made an application to change our primary signal back to UHF. Of course, we couldn't be on 56. We chose 25 was the channel number, and then. So that's where we are. We've had to change channels 4 different times. We've had 4 different channels. That meant replacing transmission line, replacing antennas, retuning transmitters, changing the mask filter. Those of you with HD radio, you know what your mask filters are. People on television, of course, it's the filter that takes the signal from your transmitter and makes sure that there's no emissions outside of the 6 megahertz channel that you're supposed to occupy. So they're expensive. Sharp slope filters to cut the edges off the channels, so there's no spurious emissions coming out of the transmitter that would affect other people.
Is this kind of filter you're talking about, is this done at high level RF?
Yes, it's done at high level RF. So in the case of my station, our TPO is about 56 kilowatts or so. Okay. We put about 57 into the mask filter. We lose a little bit through the filter, but it is a large assembly that is about 20 feet square, probably, maybe 17 by 12, maybe probably 17 by 12. It's not 20 feet tall. Takes up a huge chunk of a room. It includes a combiner to combine 2 transmitters. Through a Magic T switchless combiner, and then through a big mask filter that performs the magic and chops off the things that are outside the 6 megahertz channel. So it's channel specific, yeah.
So let's move the conversation a bit to audio. How did your audio world change in the digital transition or your HD transition?
Well, we had installed several years prior to turning off the analog transmitter, installed a standard def digital video plant with an AES audio plant, there's an AES router and an SDI video router, And while the SDI video, SDI means serial digital interface, while the SDI video can carry the audio along with the video in what's called embedded audio, we built a facility that was all discrete audio, which meant that you had to run two cables to everything. You had a video cable and an audio cable. Even if the video cable had audio on it, because it was embedded, we weren't using that audio, we were using the separate cable. So we made a separate color code, so you had two cables going to every piece of equipment, and then if it was a tape deck, you had two coming back out of it as well. When we migrated to HD, we chose, of course some time had transpired from the time we converted to just standard digital. We made the decision to do all embedded audio, because other than just a few places in the TV station, there's really no reason to separate the audio from the video. Everywhere you separate it, there's a possibility of creating a lip sync error where the lips, where the audio is not matching what people are saying. So it also makes it simpler because it's one cable going to a piece of equipment, and one coming back. It's not two. It's half as much routing equipment, half as many distribution amplifiers. It's just 50% easier. It also can carry more audio because an AES audio standard, the AES 3 standard that we live under, carries one audio pair on a cable, whether it's balanced or unbalanced. You get, one left, one right. You get a pair of audio, whereas an SDI signal can carry up to 16 audio channels, 8 AES pairs. So it's much simpler. So if you needed to carry, say, television, most things we do have surround sound, so that's left and right, center, low frequency, and then 2 surround channels in the rear, so a total of 6 channels, or 5.1 as you hear it described. Well, that's 3 AES pairs, so that easily fits in SDI. That's one cable. That's your video and 3 audios. It gives you space for other audio or other ancillary data. It's a quite elegant, to be fair. It's a very elegant, simple system. People might say, well, aren't there reasons to separate your audio? Well, sure, of course they are. If you have an audio mixer, audio console, where you're doing newscast, where you've got microphones and sources coming into an audio console, a traditional board like a radio board, of course, that's all discrete audio, and it's there's some analog, there's some AES there, so we handle it like a traditional console would, and then we put it back in the video. We go back into an embedder. In this case, ours is a frame synchronizer that ties the video back to our house time code standard, or our house time standard. It puts audio back on it as well. So, and that's where we can adjust the lip sync issue. So if we have a lip sync issue, we can adjust it there.
Tell me about lip sync. A lot of us as consumers, as radio guys that aren't necessarily in television, we've seen this, we've experienced it. Where does the problem normally?
Yeah, it was going on 45, 50 years ago. It's called Godzilla.
It's alternate audio, Gibson.
That's right.
So at what point is it most typical that lip sync errors creep in, and at what is the point where it needs to be right, or where do you correct it?
Well, the point that it most likely to creep in is anywhere it's separate, anywhere the audio is separate or takes a different path. So if you process the audio, say you've got a compressor or a limiter, or you've got something that maybe you're doing some delay. In the case of the frame synchronizer, you might add a frame of video delay, so 33 milliseconds of video delay, to make your video match your house timing standard. Then you need to also account for that 33 milliseconds in the audio path.
Okay.
Or if you go through a console, like every digital console has some delay, and it's usually a published spec, and you can look at it and you can work from the published spec. Generally what we do is we just watch it. We'd sit there, get somebody to sit in front of a camera with a microphone, and just to watch it. And I'm talking about the things that we control, like our newscast, our news audio. So we just try to make sure that it that it's close, that it looks right. But the other place it can get messed up is when it comes from a network, because often it comes in on satellite.
Yeah.
And we have to. It comes in, say in the case of CBS, CBS delivers audio with the Dolby E standard. Are you familiar with Dolby E? It's an AES 3 compliant data stream, but it supports up to 8 channels of audio.
Okay.
It's a compressed data stream that meets that 1411 kilobits per second maximum. So it's, compared to say AAC for HD radio, it's a lightly compressed signal, but it is still compressed and puts 8 channels into one AES signal. Well, we've got to decode that. We've got to break it back into the AES, and then we've got to embed that back in the video. So that's 2 separate things: as a Dolby decoder, and then as a frame sync to put it back with the video. All of those are places where you can have timing errors. Those are places where you can create that Godzilla moment, where things just don't line up.
Is it more typical that in routing around a plant that video gets delayed, or is it more likely that audio gets delayed? Which one do you usually have to make up for?
Usually you have to make up for video delay. Usually you have to make up that the video is behind the audio. That's the most common. Is it something is processing the video, like you're running through a video switcher to putting the logo, just like you're putting the logo at the bottom of this screen. Well, there's some processing time there, and so you have to account for that. Usually the video has more bits to it, so that it's more computationally difficult, and so that's usually where the delay comes up.
And as you mentioned earlier with the frame synchronizer, 1 frame of video is, you said, I think 33 milliseconds, right?
Right. Yeah. Mm-hmm.
And that's a significant amount of audio delay. Now, not for an IP codec, but for a live audio mixing system, whether it be frame based, whether it be a MADI or AES based, or whether it be IP audio based.
Exactly.
That's a lot of time for audio.
Yeah, it is.
Okay. It is. Exacerbating that is the fact that our brains have less problem seeing audio, seeing the sight first and hearing the audio a split second later, because
if the audio trails, if the audio trails, you can make it up. I mean, something about your mind can perceive it.
The brain is okay with that.
The brain's okay with it. It can say, yeah, it's not quite right, but I can live with that. But if the audio comes first, it looks, it looks like a chicken talking. It just looks funny.
Well, it'd be like hearing the thunder and then seeing the lightning. Or it would be like hearing the crack of a bat from the stands and then seeing the batter hit the ball.
That's right. That's right.
It wouldn't be right at all. The brain goes,
it's not right at all. Yeah, right. It's not supposed to be that way. That's right.
Yeah. And that's fascinating. So talking about audio, and I mentioned IP audio there. I'm curious about video over IP. And I take it from everything you've described, you're using SDI. That's not IP. Those are
it's a serial string. That's right.
Serial stream systems. So your switchers are not inexpensive. They're purpose built. That's what the phrase I'm looking for. They're purpose built.
That's a great term. Just like an audio processor, it's purpose built. Right.
Yeah. So tell me about the world of television, though, internally in a TV station transitioning to IP video, or IP transport and routing.
Well, most of what, IP comes in to a traditional TV station probably in 2 ways in video. The first and foremost for stations like mine that are in the news gathering business is cellular backpack video. So you're using IP codecs. You're compressing the video out in the field with a small computer mounted on someone's back, or put in a box, or somehow mounted near a camera, that uses that takes the incoming video and compresses it to fit on several different IP networks. Usually those are cell phone networks, like a cellular data cards, maybe 5 or 6 or 7 or 8 cards, all carrying some data back to the station. So it packetizes the video, breaks it into, say, different chunks, 7 different chunks, sends it across 7 different cell cards, where they're received back at the station on a common internet connection, and then put back together. It's kind of like Humpty Dumpty, puts it all back together again, and then it spits out the video. Of course, it's bit reduced, and so it's not the same quality as it started with at the camera out in the field, but it's passable, and that's IP video. But that's really an IP bridge, if you will. That's a purpose-built appliance to take IP, to bridge a problem, which is to get video from a remote network when you have very limited bandwidth.
Yeah, the cell carriers don't carry SDI very well, do they?
Not at all. Not at all.
Right.
And if you don't have a satellite truck, you don't want to pay for some sort of high bandwidth link. That's how you do it. Now, cable networks, most cable networks are all IP internally, and so they route everything. Everything is packetized and put on a gigabit network, what they call it, So almost every bit of video inside a television cable company, and this extends to satellite companies like DirecTV and Dish Network, are all IP based. So it's serial, it's continual data. It's mostly UDP packets, but it is IP video. So we have a little bit of it. We have some places, usually at the edge of our building, at the edge of our signals, where we encode our video, take the SDI and we compress it to send to our transmitter through our MPEG encoder. Well, that encoder also has an IP out. Currently, it's not plugged into anything. It could be. I could pass it over a common Ethernet network. If I had a private Ethernet network, I can make a 19.39 megabit per second IP stream. Or actually, I do make it. It's just not going anywhere. I can send that. I could send that to a cable provider, and they could put that directly on their network. Cable networks love IP. Cable companies love it because they can route it around. They can take it from one head end to another, and it's very efficient when they're talking about things that are, 10 megabits to 50 megabits. They can put a lot of those on a gigabit Ethernet pipe. So it's really about the ease of distribution. I think would be the easiest way of putting it. IP video routing in a facility is still quite new. There are some companies building equipment for it. I believe ESPN in Bristol, Connecticut has a big IP router that they have purchased. I don't know what status it's in and whether it's in service yet. But the big TV equipment vendors are making IP routers. But really, they also have to make the backplanes. It's not just buying equipment from Cisco or Foundry or somebody. It's building a backplane designed to switch at least 3 gigabits per second in serial packets, probably more like 12 gigabits. Because if you're going to build a router, if you're going to build a facility, you want something to last into the future. So HD video is 1.5 gigabits per second for 1080i or 720p. To do 1080p, you double it, 3 gigs a second. To do 4K, you're at 12 gigs a second. So it takes an inordinately large amount of bandwidth, and so your IP routers, your IP video routers have to be sort of pushing the edge of what the silicon can do. And so that's new technology.
Gotcha. Wow. Okay. Do you see TV stations that have, in the last few years, built out with a new SDI plant and as we mentioned, a purpose-built SDI router? Do you see any reason for them to transition to an IP routing system internally? Because their gear's pretty new at this point.
Yeah, not at this point. I mean, my SDI router's 10 or 12 years old, and it still functions very well. It's still serviceable. I can get parts for it. But at some point, it's a conversation that we'll have to have. Is what is the next router, and do we move to IP? And is the answer to that question that you're moved to IP simply because it's new and because you got to do something, and why not? Kind of like changing the color of your coat or changing a tie. You want to change just because change is out there? I don't know. I've not yet looked at the economics of it to know whether it makes sense for a TV station, because in terms of the matrix size, I think where it really shines is where you have an inordinately large matrix, where you're trying to switch, over 400 or 500 sources, both in and out. My plant is not that large. I'm about 256 or so in, 256 out. So while it's quite large, compared to say what an average radio station might have in terms of number of sources, it's still small compared to what a network like ESPN or NBC or CBS might have in their facilities.
That makes sense.
Yeah.
Good deal. Hey, we're going to take a quick break here and hear from the folks at Axia, because we're on the subject of IP and they're a sponsor. And then we get back with a couple more things to talk about before we close out the show. We're talking with Gibson Prichard on This Week in Radio Tech, and he's the chief engineer for Channel 5 WTVF-TV here in Nashville. Hey, Axia is a sponsor, and I got to tell you, one of the things that I really love about audio over IP and the pioneering work that Axia did on this is sound card replacement. Hey, at my own radio stations, I've got 6, maybe 7 PCs, some running Linux, some running Windows, that have no sound card. And yet I have absolutely bit for bit perfect real-time audio transfer in and out of those PCs. The applications that are running, they don't know the difference. They think it's a sound card, either in the Linux operating system, part of the ALSA mixer, or part of the Windows operating system, because the Axia IP audio driver looks to the operating system like a sound card. And so you can make an Axia driver the default sound card. So applications that don't otherwise choose a sound card device, just use it. Or if you have maybe a multi-track editor or some other application that lets you choose which sound card to use, well, you just choose the Axia IP audio driver. And this means you get absolutely, let me say it again, bit for bit, perfect audio transfer in and out of the PC. You don't lose anything, not even, let's see, it's 24 bits. So that's like 132 or 136 dB down. I mean, it's 2 levels of quantum. I mean, it's just enormously better than CD audio. It's good stuff. In fact, at station after station, when either I've done an installation of an Axia AOIP system or one of our other staff members has done that, they report, wow, we can't believe how much better the station sounds. I mean, there's a big national radio show that's produced just down the road from me here in Nashville with, I want to say, 6 million listeners a week. And we put it on the air, the Axia system. This was years ago, like 7 years ago. And bam, I mean, instant. It was obvious, even over the satellite, over the affiliates, it was obvious that the audio quality was better. And they didn't have bad equipment beforehand. I just heard from one of our engineers that just did some work here in Tennessee, a good-sized market here in Tennessee, said we replaced a control room with all Axia IP audio gear, and bam, you could hear the difference on the air. You wouldn't think so. I mean, it surprised me. Well, the Axia IP audio sound card is a big part of that, because that sound card, a traditional sound card in a PC, man, I mean, quit futzing really with 3.5 millimeter plugs and unbalanced stuff, or even XLR connectors and balanced stuff. All that expense, the drivers that go out of date when, Windows makes you upgrade to something new, like Windows 7 or 8 or Windows 10 coming along. All that stuff, none of that changes. All you do is use another network card, stick a network card in there that does gigabit, and install the Axia IP audio driver, and bam, you have got perfect audio in and out of that PC. If you're just doing sound card replacement, if you're putting PCs on a network to play audio for maybe automation work, for a production machine, for a logging machine. Hey, I've got a logger at my stations in both American Samoa and in Greenville, Mississippi, and PC just runs. It's got a second NIC on it plugged into the Axia network, and we have access to 24 different stereo channels on the network. If we want to log what's happening with one of our crazy satellite receivers 24/7, we can do that just by typing a few things into the logger. In other words, no additional wiring. My wiring for the logger consists of one Ethernet cable from the Axia switch going into that PC. It's been the biggest boon to wiring to not have to futz. And that's the nice word with audio cards. It's just, I can't tell you. So go to Axia Audio. It's one of the big reasons that you should go to an AOIP system. And Axia has been making IP audio drivers longer than anybody else. We came out with those things, I guess, 10, 11 years ago, and they're just terrific. I can't say enough about it, except now I'm running out of time. Just one of the benefits of going to AOIP, especially Axia AOIP. Oh, should mention, the IP audio drivers also handle virtual GPIO, and that means that contact closures don't require additional wiring. It's the same piece of wire. It's the same RJ45, the same network, and you get contact closures in and out of your automation system, your logging system. They're just there, and they just work. Really amazing stuff. So check it out at axiaaudio.com, and you'll just be so delighted that you got into that world of AOIP with Axia, because it does work so well. All right, we're just about to wrap up episode 238 of This Week in Radio Tech. I'm Kirk Harnack. I'm talking with Gibson Prichard. He's the chief engineer at Channel 5, WTVF here in Nashville, Tennessee. Self-taught in engineering, started in radio, and is now chief engineer at probably the number one biggest station in Nashville. So Gibson, what was it? We were going to talk about a couple more things. Common law blog, communications law blog, and what was the other subject we were? Oh yeah, in the IT world, we were talking about routers. And years ago, I had built up a Linux-based. It was called Coyote router.
I remember that. I
they stopped. As far as I know, they stopped supporting it. No more updates were available. We used a Coyote router that I built out of an old beige box PC at our stations in Samoa for years, and it was so easy to deal with. You told me about another one, though, that you really liked. Tell me about what that was.
Yeah, I use a system called PF Sense, like Packet Filter Sense, SENSE. It's not based in Linux per se. It's based in a Unix called BSD Unix, which is very similar to Linux in that it's free. PF Sense is free. There's commercial support available. But what I like about PF Sense is it takes what used to be rather arcane methodologies to a router and firewall, where you have to learn everything at the command line and you have to do all of this stuff. If you want a enterprise grade router that doesn't have a big networking company's name on it, like Cisco or Foundry Networks or something, you had to pay big dollars for that. What PF Sense does is put it in a GUI, all accessible through a web page, and it's quite fantastic. I used it for a long time here for News Channel 5 here in Nashville. I use it at my house, and I'm able to do great things with it. It has all sorts of features. You want to do filtering. You want to look at you want to take Susie, the receptionist, and say that she can't go to her eBay site. Well, you can block that. You can block it per user. You can block it per everybody. You can do logging. You can tie it to Active Directory, and it's all free. So you can take the people's user's name, take the name that they log into the computer, authenticate them, give them internet rights that are specific to their username. You can log it. It makes a great VPN endpoint. Mm-hmm. So if you want to be able to access your building remotely or access your site remotely, it's great. I can't say enough good things about it. There's commercial support available, but you don't have to pay for it. If you don't want to pay for it, you can do it yourself. There's a lot of tutorials online. You can build it from an old beige box. You can take any machine that's basically Pentium 2 or faster. If you need to pass more than several hundred, probably more than 50 or 60 megabits of traffic, something better than a cable modem, you need something like a Pentium 4. But you can buy appliances these days. You can build an appliance. Most people have cast-off machines that used to run XP that they've replaced for some reason. Got a Pentium 4 processor in it and 512 megs of RAM. I mean, it only needs I think 32 megs of RAM maybe to operate. Some of that matters how much encryption you're doing. If you do a big VPN system, you'll need some processor just to handle the encryption and de-encryption process. But it's really simple. It's a simple installation. You can back the settings up to an XML file. They're human readable. You can open them in a text editor. You can copy it. You can make a system. You actually can have two of them in a failover with a third NIC that ties the two together for a heartbeat. So if one should fail, the other one comes online. Everything your corporate IT department says you needed to pay $10,000 for a commercial firewall, you can do with PF Sense. So it's as robust as you want to make it. Dual power supplies? Well, buy a PC with two power supplies.
Sure.
Put two PCs and tie them together.
I've long been a fan of the MikroTik routers, the router board OS, and but programming them can sometimes be a little cryptic. And I think you and I got started talking about this because I told you that the router board OS, it's a little difficult to do packet prioritization based on the content of the packet. There are a number of criteria that you can use, but I'm not, and I may be wrong on this, but I haven't yet found how you determine, it's an RTP, real-time protocol packet, maybe for a VoIP phone. I want to prioritize that kind of packet on an outgoing basis. And I haven't been able to do that in a MikroTik router. but and many other routers let you do that.
Yeah, that's
I
true.
love the idea of building up my own router with an old, like you said, a cast-off PC. But like you also said, you can buy appliances that are already pre-configured with pfSense if you want to.
Yeah, you can find it on Amazon or eBay, or the pfSense has a store. You can buy them. They're reasonably priced. They're around $200. It's more expensive than one of the common routers that you might buy at Walmart or any sort of other store, but it does a lot more. So you get what you pay for. It's not. It's certainly less expensive than a commercial firewall and does about what a commercial firewall will do, sometimes more. So it's certainly a lot, certainly something you should look at if you are responsible for your company or your TV or radio station's connection. It's a great way. It's a great way to protect you from the things on the internet, as well as to do all kinds of things you'd never dreamed possible.
I want to close out on a note that goes back to what you said earlier about being self-taught in broadcast electronics and broadcast systems. I think probably the way that I've learned, and I wouldn't pretend that I know everything about it, but I know a lot about IP, about packet handling and routing and filtering and that kind of thing, is by doing it myself. And I've always had this crazy interest in routers, or crazy, at least enough of an interest in routers to get what I want to do done successfully.
Yeah,
and
sure.
I'm a little surprised sometimes at how much misinformation that there is out there, or people get used to using one router. They think that's how it's done, when in fact there may be lots of other ways and maybe better ways to get something done. Well, if you will just take a cast-off PC and build up your own router using Coyote, which I used 10 years ago, or this pfSense, you're going to educate yourself quite effectively into how this stuff
and you'll find if you're trying to do IP audio, you'll find all the tools in pfSense to do it, to be able to watch the packets, to see what's going on, to prioritize voice over IP or audio over IP packets. You'll be able to teach yourself the things you need to do to be a network, to safely, securely administer your own network. All the tools are there. If you can Google for the question, you can find the answer. And it's something, if you're willing to go to your toolbox, pick up the screwdriver, the hammer, and the set of diagonal wire cutters, and go fix a problem in your radio station, you can, you probably also are the type of person who can who wants to be able to fix their own computer problems or fix their network issues. And I think a lot of that goes, what's at the heart of that is understanding it and being competent, feeling like it's not black magic, like it's not the guy behind the curtain, but it's you being in charge of it. And I think that's something that learning your own router teaches you a lot about, about what's going on.
I kind of like being the guy behind the curtain.
Well, you do that well, Kurt.
Hey, unfortunately, we are out of time. We have sped through an hour of chatting about television and audio and IP and some IT stuff with Gibson Prichard. Our show has been brought to you by the folks at Lavo and the Crystal Clear Audio Console, the touchscreen console. Also brought to you by Omnia and the new Omnia 7. Go check it out on the website at omniaaudio.com/omnia-7. You'll be hearing more about that. It's really affordable. And it's been brought to you by the folks at Axia. And one of my favorite things about the Axia AOIP system, about Livewire, is sound card replacement with just a $15 network card and the IP audio driver. I use it in all kinds of places. Check it out, if you would, at axiaaudio.com. So Gibson Prichard, thank you for being with us. I really appreciate your quick notice joining our program tonight.
It's been fun. It's been great. Kirk, thanks for having me.
Oh, well, have you back again sometime, especially if you rewire the whole TV station again. Be sure you tell us about it.
Well, by the way, just like you, I have one of the 300 millimeter tower beacons at my house too. So
really,
I do. I have it sitting on my back porch. When we relamped our tower, I kept a beacon.
Did you? Do you still have the full size bulbs in it?
It is still. I actually put a cord on it. Yes, I can plug it in. It will put 1,300 watts of light out over my neighborhood. Yes.
Well, I don't have mine on the back porch. We don't live in a red light district like you do.
Yeah.
But mine's here in the office, and it lights up the office pretty darn well.
It's a great sign that Rudolph is on the way.
That's a good idea right there. We should put it out for Christmas Eve.
That's
Hey, again, thanks for being with us. Next week, I remembered who our guest is next week. It is a guy. It's radio. He won an award from Radio World magazine. It is who is it? The what is it that he won here? He was awarded. Oh, the Radio World Excellence in Engineering Award. Okay, all these awards have different names. The 2014 Radio World Excellence in Engineering Award has been bestowed upon Wayne Pacina, who is an educator, and he does these SBE webinars where he teaches all about different aspects. So typically, it's IP systems, IT, information technology, networks. And Wayne is going to be our guest on the show next week. So the guy who usually does all these webinars is a great educator and a fine Southern gentleman from Texas. He'll be on our show next week. And then we're going to take a couple weeks off for Christmas and New Year's. So a couple of programming notes there. I hope you'll be sure and join us for next week's show with Wayne Pacina. So there you go. Gibson, thanks again for being with us, and we'll see you all next week on This Week in Radio Tech. Bye-bye, everybody.